Hi everyone, it's Tara. Welcome to my channel. I have been playing through the attacking and defending AWS path in TryHackMe and making some video walkthroughs. I'm currently in the middle of the module focused on IAM, Identity and Access Management in AWS. In my most recent video, I played through the room that's focused on IAM Principals, which is kind of like the who, typically you can think of it that way in AWS IAM. And now the next room is focused on IAM permissions. So I'd like to think I'm pretty good at writing IAM permission policies and understanding them. But in my experience, I have seen that even the greatest IAM pros out there can definitely have some humbling moments. So I'm excited to play through this room, see what it's all about, hopefully learn some new things and get some practice with IAM permission policies. So let's go check it out and see how it goes. Here we are in the introduction to IAM module, and the next room is IAM permissions. The description for this room says learn how authorization is handled in AWS IAM. So, IAM principles was about the different types of actors in IAM that do actions, and now we're going to learn how actions are authorized via permissions. Let's jump in. Now I am in the IAM permissions room. The first task is called structure of an IAM policy. An IAM principal can have multiple policies attached to it. These policies determine what the principal is authorized to do in your account. So remember, when you hear principal, we're talking about things like IAM users and IAM roles. That's what's meant by principal. Each policy consists of one or more statements that consist of an optional statement identifier, so that's the SID, an action, which is a list of the things that the policy either allows or denies the principal to do, resources, which is the ARN or ARNs of resources in AWS that the statement applies to, an effect, which can only ever be allow or deny. That's the only two options. And then lastly, conditions. So you can use optional conditions in the policy, and those conditions must be satisfied for the policy to actually grant permission. And conditions in IAM policies are very powerful. Hopefully, we'll be seeing that in this learning path. But once you know how to do conditions in a permission policy, you can really do a lot with that. This provides many AWS managed policies that contain a list of actions that usually map to a specific job function. However, AWS customers can also create custom policies that are more fine grained. For example, you could use like this resources clause in a permission policy to say they're only allowed permission to this one specific resource, this one S3 bucket. Customer policies can be either customer managed policies or inline policies directly attached to a specific principal. Inline policies are attached to one principal inline, hence the name, and they can't be shared or reused, whereas customer managed policies exist as their own thing as a policy, and then you attach it to different principles as needed. So customer managed policies are better for reuse, they're better for editing at scale, and typically customer managed policies are the best practice as opposed to using an inline policy. Anyway, I'm in here like 3 minutes, I'm already on a tangent, so let's see what we're supposed to be doing here. Inline policies are best to ensure a direct relationship between a principal and the policies granted. In contrast, managed policies can reuse the policy across multiple principals. Exactly. So just think customer managed policies better for reuse. The most powerful AWS managed policy is the administrator access policy shown below. So this is the managed policy. AWS creates it and manages it. You don't edit it. And the administrator access policy is essentially like God mode in AWS. If you have this policy attached to your user or to the role that you've assumed, you can literally do anything in that AWS account, with the exception, I think, of if the account is in an organization. But typically, when you see administrator access, that is full permissions in AWS. This is a very significant permission to have attached to somebody. And let's see, this is just an example of what that policy actually looks like. So you can see the effect is allow, the action is this asterisk wildcard. So this means everything. Everything matches this wildcard. And then a resource is also the asterisk wildcard, meaning again, everything. So every action is allowed on every resource. That's what makes this such a powerful policy. So this is saying kind of the same thing, point out that really important part. This is called the statement, allow on everything. In the remaining tasks in this room, we will go through all different elements of an IAM statement in more depth. There is another managed policy called read-only access. This is a very nice managed policy. Using the commands above, go look at the permissions granted to the read-only access user. At the time of this writing, the version ID was version 83. Use the AWS CLI as shown above to answer the following questions. Okay, so they want us to mimic these commands that were shown in the example to assess what the policy looks like for the read-only access AWS managed policy. So I've not logged into my cloud sandbox yet. So that'll be the next step so that we can run commands. And this is very exciting because I've been wanting to see if the cloud sandboxes here in TryHackMe are a persistent account we're using more than once, or if a new account is spun up for us every time we come in here and do a new room. So this will be our opportunity to solve that mystery. Let me just pull up the cloud details here. My environment is finished spinning up. Remember, that's what that active state means. And I have my credentials here to get into my sandbox environment. All right, I switched over to sharing my entire screen here so that we can see the terminal and the web browser. And I did a little investigation and I determined that this is indeed the same sandbox AWS account that I was using a couple of days ago in the IAM Principals room. So if you're curious how I confirmed that, there's a couple ways. So first of all, you might remember if you watched my, I think it was the IAM Principals video, that I set up an AWS command line profile with my credentials for the cloud sandbox that TryHackMe had given me in that other room. And that was like 2 or 3 days ago that I was doing that. So first, to see if that sandbox environment was still up and running and accessible with the same credentials, I just tried to run a simple command using the AWS CLI, targeting that account, using the profile I set up a couple days ago with the credentials that TryHackMe gave me. So I just ran this AWS S3 LS command. That is like one of my favorite commands to have in my back pocket. I always use this to see what account I'm logged into. This is the profile I set up a couple of days ago. And I can see that this command returns a TryHackMe bucket. So the credentials I was using a couple of days ago are still valid, which made me think, okay, so this is probably the same environment. And then when I navigated over to the credentials tab here, I'm not going to show it to you because now that I know these credentials are going to be reused throughout the path, I want to make sure and keep them private. But I also did a quick check of the credentials file that the AWS CLI creates when you configure a profile. And the credentials in this credentials file for the AWS CLI do match the credentials that TryHackMe is giving me in this room. So anyway, all of that to say, very long-winded explanation. This is the same AWS account I was using before. It's not a fresh account every new room that I'm in. So that's interesting knowledge to learn. Now, with that all being examined, let's go back to the actual task of the room. I tried to arrange this a little bit better, so hopefully it's a little bit readable. Let's clear the terminal. And I believe our task here was to examine the read-only managed AWS IAM policy. I believe what we were trying to do was we want to reuse these commands that it looks like our friend Chris was running here in these examples, but instead of examining the contents of the administrator access managed policy in IAM, we want to learn about the read-only access managed policy. So I'm just going to reuse Chris's command here. Hopefully I can copy and paste. But instead of the administrator access, I'm going to do read only access. Hopefully that's the correct name. And Chris didn't do this because he was probably had his CLI configured differently or was using his default profile or something like that. But I'm going to use this profile flag to target my TryHackMe profile. Okay, let's see if I got this right. Perfect. So here's what that command returns for the read-only access policy. So we can see different policy name, different policy ID, the ARN. The reason we were able to run that command so easily, just changing only the policy name, is because ARNs are constructed the same way every time. And for IAM policies, the only thing that really changes is that policy name there. And then we can see the version. So it looks like this is quite a bit ahead of the version they were using when the time this was written. And then the description provides read-only access to AWS services and resources. So that's the first command Chris ran. And then let's run this second one so we can do, oh, and this is why they gave us the version, so we can get the exact version here. So we're going to do, so instead of get policy, now we're going to do get policy version is the actual command. And then once again, we just need to change this to read only access. I'm going to use, oh, and then I think there's a version flag I need here. Yep, perfect. Okay, so let's see what they said it was. V83. So we want V83. And then once again, I need to use that profile flag. Oh, oops, what'd I do? Oh, case. Aren't I so proper trying to capitalize everything? Let's try this. Okay. All right, and there we have the policy contents. So we can see this is quite a long policy as opposed to the administrator access that just had those wildcards for everything. But the effect here is allow, and the action is for all these different services, basically a lot of these get and list actions. The idea is this policy lets you go into AWS, look at everything, read things, but you can't actually update, delete, create, that kind of thing. So if you're following along, you could definitely take the time to parse through this, but hopefully you get the idea. And that was interesting to see the actual contents of that policy. Back over to the room. Let's see what the question is for this task one. What is the policy ID of the read only access managed policy? Okay, hopefully I didn't just close my terminal. I don't think I did. Um, Oh, but I did clear my output. So let's see. I think that first command gave us the policy ID. So I'm going to run AWS IAM get policy again. And let's see if I can get the policy ID from this. Policy ID. Hopefully this is the correct value. And whoop whoop. Okay, so that is task one complete. And now I'm going to move on to task two. Looks like this is a reminder of how to access our cloud sandbox. So we were looking at that a moment ago. Here's a reminder that if we need to generate an environment for this room, if we need to like probably spin up infrastructure for this room, there will be a generate environment button. So let's scroll up and double check if there is a generate environment button. Okay, so that's what I thought. So no need to generate anything. It looks like we're just using the AWS account and we already know how to access that. Here's an example of what the credentials tab does look like for the AWS account and nothing we need to do. So we can just hit completed and move on to task three here. Task three focuses on the action part of the IAM policy. Actions consist of a service and an API call. Some examples are EC2 stop instance, S3 get object, STS assume role, IAM list users. So this first clause is the service, EC2, S3, STS, IAM are all AWS services. And then the second clause, I don't even know if I'm using the word clause right, but hopefully you get the idea, is the action or the specific API call. Oh, so this is saying the same thing. Which part is the service and which part is the API call? Actions are case insensitive. However, service names are almost always written in the lowercase, and API calls match the camel case in the AWS documentation. I actually don't think I really knew that spelled out that way. So let me read that again because I want to lock that to memory. Actions are case insensitive. However, service names are almost always written in the lowercase. Okay, that tracks. And API calls match the camel case in the AWS documentation. I'm going to remember that. Actions support wildcards. So to permit all the actions for the S3 service, you would use that asterisk wildcard that we talked about before. And to scope read-only actions, you could say S3 get and then wildcard, which would allow all the actions that start with get, which translates to read-only. This does not enforce consistency across services for API calls. I think we learned about that in one of the introductory rooms because of like the whole two pizza team idea. So some services use describe while others use get or list, and those are all read type of calls. The complete list of IAM actions can be found here. If you write IAM policies on a regular basis, you will probably want to bookmark this link or just be like me and Google it clumsily every time. Before we move on to the question, let's go ahead and open this link. This is the service authorization reference document. So, this is basically like the documentation you can refer to as you're trying to write your IAM policies. And let's see, probably like a good example here would be S3. So, this is the Amazon S3 service, but you can see this is a list of all the AWS services. And when we click on S3, we can see in this actions table, this is a list of all the different actions within S3 and then a description of what that action is. So sorry, I'm scrolling around kind of fast, but you can see this is the action abort multi-part upload. Sorry, the first one on the list is not like the most illustrative, but I want to be able to see the headings. So this is the action you can do in S3. This is a description of what that action is. And then this is the access level. So this would be a write action. Create bucket is maybe like a more graspable example right off the top. So create bucket, if this is included in an IAM policy, it grants permission to create a new bucket, and it's an example of a write action. So that's what this document is, and it's very useful. And they're right. I probably should bookmark it. Let's go back and see The question for task 3, what action grants permission to create access key and secret access key for the specified IAM user? I'm not sure that's written correct. I'm not sure that was written correctly, but the quotes make me think it's probably like right from the documentation. So it's probably not TryHackMe's fault. Anyway, you can find a hint in the service authorization docs for IAM. So I think that's kind of what we were just looking at. But instead of S3, we want the IAM service. I think this is we're looking for like probably create access key here, but let's just double check the docs to make sure. So here is AWS Identity and Access Management, IAM. And let's see if there is a action here. We can scroll down to the action table. Let's see if there's an action here like create access key. Yep. Okay. Create access key grants permission to create access key and secret access key for the specified IAM user. And this is a right action. I think this is going to be the answer to the question. Let's see. Okay, and looks like we can tell by these placeholders here that we want that same format we saw earlier. So we want I am and then the action. Let's give it a try. Whoop, whoop. Okay, so I am create access key was the answer here. We learned how to reference the actions table in the docs to find the permission that we're looking for. And that's the end of task 3. Let's move on to task 4. Task 4 is called resource. We're going to focus on the resource part of the policy. A resource is always in the ARN format or a wildcard, which would represent any resource. Resources in IAM policies are essential to achieving the principle of least privilege that we learned about in, I think, the intro to IAM room. Suppose there are multiple applications or teams in a single account. In that case, least privilege would dictate that application A cannot access the data belonging to application B unless there's some business need to do so to share that data. So we could craft, for example, a policy that only permits application A to access S3 buckets that belong to application A and deny them permission to buckets that don't contain data for application A, even if all those buckets are in the same account. So that's an example of why resources is useful in the policy. Recall that the ARNs include the AWS region, account ID, and resource name as part of the ARNs. ARNs that are global, like IAM, for example, have an empty value for the region. You might have noticed that above when we were running those commands to examine the IAM policies, that those ARNs we were using for the policy did not have a region because IAM is a global service. Because IAM cannot identify what resources a customer may have, all AWS managed policies, the wildcard I think there's a typo there. Because AWS cannot identify what resources a customer may have, that's an unknown, all AWS managed policies use the wildcard as the resource value. So that makes sense, right? When they create their managed policies for everyone, they don't know what everyone's bucket in the world is going to be called or all the future S3 buckets that are going to be created. So they can only use those wildcard. And so that gives you an example of why it's challenging for those managed policies to be least privilege policies, and you might want to use them as a base to then create your own customer managed policies that do use resources to scope down the permissions given. And in the case of the ARN for an AWS managed policy, since these are managed by AWS and not owned by anyone's AWS account, the account ID field in the policy ARN is an empty value. So let's see if we can see an example of that up here before. This is what they're talking about. So in this AWS IAM get policy command, we're sending the policy ARN to the command to get the information. And you can see this is the ARN, the resource number for the IAM policy. And because this is an AWS managed policy, this ARN does not have a region in it and it does not have an account ID in it as well. That's what they're getting at here. And that's an example of that. Let's see. Oh, that was it. Straight to the question. In your account, there is a bucket that begins with TryHackMe bucket and ends with your unique account ID. What is the ARN of that bucket, excluding the last 12-digit account ID? That'd be different. Because that account ID will be different for everyone. So that's probably why that question is formatted that way. Now, actually, you might remember I jumped the gun here because earlier when I was just trying to like investigate the environment a little bit, I already ran a command that can give us the answer to that question. So I'm going to run it again. So I'm going to run AWS S3 LS. I'm going to target my TryHackMe profile, as I mentioned before, and let's see what that bucket is called. Okay, so we've got TryHackMe bucket, and we want the ARN of this bucket. So this is our bucket name. Let's see how S3 ARNs are formatted. All right, perfect. I could have tried to do this from memory, but I would embarrass myself. So here is an example of how S3 ARNs are formatted. So I'm going to get the first part of that here. And then I'm going to, looks like we just need the bucket name there. And they said without the account ID, I don't know if they want this last trailing dash or not, but let's give it a try. Okay, let's see if I get it right. All right, awesome. So that's task 4. And now on to task 5. I am having a lot of fun in this room so far because I like running these different commands. Let's see what task 5 has. Task 5 is about the effect part of a policy. So remember, effect only has 2 options, allow or deny. Effect can be either allow or deny. With AWS IAM, there's a default implicit deny. We talked about that in an earlier. All policy statements that match the request's action, resource, and condition are evaluated. If there is any explicit deny anywhere in the policy evaluation logic flow, then the action is denied. Otherwise, if there is an explicit allow, the action is allowed. Nothing will ever be allowed without an explicit allow somewhere in a policy. Otherwise, if neither like an allow or deny exist anywhere, the final decision is always to deny the request because the implicit deny kicks in. And here is a diagram explaining that same thing. Oh, this is cool. I've never seen this one before, I don't think. Or maybe I've just never seen it with this little cartoon cop on it. But the decision starts at deny. AWS is going to find all the policies associated with the user and the resource, and then evaluate all the applicable policies. There could be multiple. If any of those policies have a deny anywhere in them, that's an explicit deny in the policy. And the final decision is a deny, even if the allow exists somewhere else. If there's no explicit deny, then we check, is there an allow somewhere? If there's an explicit allow written in the policy, the final decision is allow. And then if neither the deny or the allow is there, the final decision is to deny because deny is the default. Now, we're going to answer a question for the following question, and then we're going to look at a policy and answer a question, it looks like. So this is an example IAM policy. For the statements, it looks like to me we have 2 statements, right? So this whole part is the statement block, and then this is one statement here, and then this is a second statement here. Okay, so the first statement, we have 3 actions: EC2 describe actions, secrets manager list secrets, secrets manager get secret value, and the resource has this wildcard. So that would be any resource in EC2 or any resource in secrets manager. And then the effect is allow. And then we have a second statement. And this statement is a deny statement for one resource in secrets manager. So this second statement says you cannot do anything with this one particular secret. So it's using the resource part of the policy to say this one secret is off limit because the effect is deny. Given the policy above, can this user get the HR password? Yes or no? Okay, so the secret we're looking at is this HR password they're referencing. And even though this user has, sorry, I paused so many times. Oh, sorry, I'm like started speaking in slow motion. Okay, so even though this user has permission for get secret value for any resource, because there is an explicit deny in the second statement that overrules this explicit allow, the answer is no. So because of this deny in the second statement, the user cannot get this one particular password. So the answer is no. We're going to do N. And whoop, whoop, that's correct. Sorry, you can't have the password. This is a great example of how explicit deny works. Explicit deny always beats an explicit allow. Let's move on to task 6, which is principal. We learned a lot about principals in the other room. Only required for resource policies, not identity-based policies. The principal element specifies the principal that is allowed or denied access to a resource. So remember, resource policies are not attached to a principal like a user or a role. A resource policy is attached to a resource in AWS. So S3 bucket is a great example. S3 buckets can have resource policies attached to them that govern access to that bucket. And resource policies require a principal in the statement. If the principal is star, the policy applies to anyone or all AWS customers, depending on the service. And we're going to learn more about resource policies in the next room. The following resource policy grants public access to read a bucket and only allows user Snape, so Snape must be like an example name here, the ability to write to the bucket. Okay, so let's look at this example policy. So this is a resource policy. This would be attached to an S3 bucket, I believe. The first statement says allow public read, although the ID I think has a typo in it here. So the effect is allow. The principal is this star, so that means anyone, and that's why this is like a public access policy. So you want to be really knowledgeable when you're using this type of policy with an S3 bucket because this is going to allow anyone in the world to access the objects in your S3 bucket if they have access to the internet. And the resource is, let's see, this S3 bucket that's called dark arts class notes. And this star here means any object in the bucket. And then this second statement, even though it has the same statement ID, this has the effect of allow for one particular principal. So instead of the star, we have this one particular principal, which is an AWS principal, which is an AWS user. We can tell from this ARN, and that's the Snape user. And the Snape user has permission for two actions, put object and put object ACL, which stands for, I believe, access control list. So this means this user could update the access control list for an object in this bucket. And once again, it's the same resource statement. So we could have any object in the dark arts class notes bucket. All right. So we can specify any of the following principles in a policy. We can specify a specific AWS account and the root user in that account. We can specify an IAM role, a role session, IAM users, which is what we saw here. This is an example of an IAM user, federated user sessions, AWS services, and then all principles, which I believe is what we saw here with the wildcard. Okay. So look in your account. What is the principal that is allowed to assume the organization account access role? All right. I do have my profile set up at the command line, but I'm not logged in the console yet. Otherwise, this is like a direct link to the console, I bet. Just like to shake it up. Let me log into the console and then I'll be right back. Okay, so now I am logged into the AWS console for my TryHackMe sandbox account. And I believe we wanted to look for a specific IAM role. So let's see what that IAM role was called. Organization account access role. We want to know what principal is allowed to assume the role. So we need to look at the trust policy for that role. So here we are in the IAM service. If you don't know how to get to different services in AWS, you can use this search bar to search for IAM as well. And we want to look at a role. We want to look at the organization account access role. And we want to know what principal is allowed to assume the role. So that is governed by the trust policy. So we're going to click trust relationships. And then the principal is this the root user in this account that is identified by this AWS account ID here. So let's copy and paste that. Probably I'm going to regret. Let's see. What is the principal? I'm trying to figure out how I've gone wrong with the formatting here, but okay, maybe that's going to be okay after all. Going to regret these quotes, knew it. And let's see what happens if I do that. No. What is the principal that is allowed to assume the role? Allow, principal. Perhaps it's this. Perhaps we need the whole thing. All right, so we want to indicate it's an AWS principal specifically. And there we go. Okay, awesome. So they wanted the whole clause. That was task 6, and now I'm going to move on to task 7, which looks like is focused on conditional logic in IAM policies. Task 7, conditions. Conditions are optional elements that users can add to an IAM policy. They evaluate against specific keys and values in the context of the request. The context of the request is specific to the action and resource type. For example, the condition keys available for S3 can be found in the S3 actions table that I think we actually looked at before as an example. And so here's the actions table, and then we can scroll to the right and we can see here's the condition keys column. And notice that there are different condition keys for each of the actions, even though I'm sure there's a lot of overlaps. For example, if we wanted to find the get object action, let's see what some of the condition keys are here. So a good example here is like S3 auth type. you could use the S3 auth type condition key to determine, oh, maybe users can only have access to an object in your S3 bucket if they have a certain sort of auth type. And we can click here to even learn more about it. So we could say, so we could require a specific authentication method to access an object in S3 using this condition key. And a common application of this is requiring two-factor or multi-factor authentication to be able to access a S3 bucket. That's a common example of how these condition keys are used. Back to the content here. This is like an example of condition block logic. So this would be a condition block in an IAM policy. This particular condition block has two conditions, condition 1 and condition 2. This and here means that condition 1 needs to evaluate to true and condition 2 needs to evaluate to true for the condition block itself to evaluate to true. In condition 1, there are two keys. So for condition 1 to evaluate to true, we would need to have a matching value for key 1, and there are three different choices. So if the value matches any of these three values in the policy, key 1 will be a match and key 2 needs to have a matching value. So the relationship here is and key 1 and key 2 both need to have values that match those keys. But within each key, there are multiple values, and the relationship there becomes or. So value 1A or value 1B or value 1C meets the criteria for key 1. And then same with key 2, value 2A or value 2B will satisfy the requirement for key 2. So that's a good example, breaking it down. Condition statements have specific operators that are used to evaluate the conditions. Examples are string equals, string not like if exists, etc. And then there are a number of global condition context keys. And this is what I would say I see used most frequently is the global condition keys that you can add to your statement based on the attributes of the API call. So one of the most common ones is AWS source IP. You can use as a condition key, and that's not specific to the action like we saw in the action table. That's a global condition key. So you can allow or deny an action based on the IP address that the request is coming from to the API. Another popular context key is AWS resource tag key. So in AWS, you can tag resources, and we can use a condition key to grant or deny access to a resource based on the tags that are attached to the resource. So this is an example statement here. So we would allow requests to the EC2 service to terminate an EC2 instance. This resource clause references any instance in this specific account. So the way we know that is because we've got ARN AWS EC2, so that's the EC2 service, and then we've got the account ID number here, and then instance. So that's how we know we're only talking about EC2 instance resources, and then the wildcard means any instance in the account. And then the condition is what's really powerful here. So this policy would only allow the instance to be terminated if this condition is met. And the condition is that the tag attached to the EC2 instance, the resource tag, the key for that tag would be Hogwarts House, and then the value would be Hufflepuff. So if the EC2 instance has a tag attached to it with a key of Hogwarts House and a value of Hufflepuff, then this policy would give permission for that EC2 instance to be terminated, for a request to terminate that instance. If the machine were tagged with Hogwarts House Gryffindor, I just said it said Gryffindor, so weird. Hogwarts House Gryffindor, the allow effect would not apply because this string equals condition would not be true. The use of AWS resource tag is a fundamental building block of attribute-based access control, or ABAC. And in the next room, we will see a global context key, AWS Principal Org ID, which is used to ensure only members of the TryHackMe community are able to invoke a certain Lambda function. That would be a great example. And then we have another example IAM policy here. So this is a policy that denies any principal the ability to put an object to S3, to an S3 bucket. And this is controlling access to this S3 bucket, my logs bucket. And then these are S3 prefixes. So you can kind of think of this as like a specific location in that S3 bucket. And then we have this condition clause, string not equals source VPC, and then a VPC ID, and then AWS principal service name. If the request had context values that match these, that would actually nullify, right, this deny policy here. This is a good So this is a good example of a type of policy that's often used for least privilege because this is denying every put object action except for from the Glue service, which Glue is a data analytics type service in AWS. It's denying every put object except for those put object requests coming from the Glue service in this one specific VPC. Now, the question is the Glue service running in VPC 12345 can write an object to the my logs bucket. All right, well, first of all, we can see that the VPC here, the VPC ID here, VPC 12345, is not the same as VPC ABD. I can't even say the alphabet. A, B, C, D, E, F. All right. So this condition, string not equals, would evaluate to true, right? Because this VPC ID does not match this VPC ID. So string not equals is true. They do not equal each other. And that would trigger the deny. So the glue service running from that VPC would not be able to write an object. Also, another thing I noticed is that the question is referencing the entire S3 bucket, whereas this policy is only talking about one specific prefix in the S3 bucket. So that might also be relevant. But anyway, I believe the answer here is false. And that is correct. So that's a great example. And let's see what's going on in task 8. Task 8, not action, not resource, not principal. AWS IAM has the concept of not action, not resource, and not principal. These can be used in more complex cases, but be careful. Ooh, exciting. Be careful. Doing an allow on all principals except one would allow all AWS customers to access the resource. And I got to say, I'm not sure I've ever used not action and not principal. I think I have used not resource before, but I'm not super familiar with these concepts. You can use not action to grant broad access to an account while reserving sensitive actions for special administrators. This is one way to allow someone to administer an account but not modify a network, for example. Not principal is useful for explicitly denying access to a resource except for a small number of users. For example, this policy will explicitly deny access to a Dynamo database table, Forbidden Forest, to all users of this account except for Hagrid. So that's like an efficient way to do that, which makes sense. So we can see this statement, the effect is deny for every principal except for the Hagrid user. Another way of protecting access to something would be via not resource. The same policy prevents most users in this account from accessing the Forbidden Forest table. So this is what I've used before, the not resource, where you need to explicitly deny, except like to some very specific principal, a certain resource. I've seen it used with S3 buckets before. Now, all students in this policy have access to put to any DynamoDB table except the Forbidden Forest table. And that's because we are allowing any user, because it's any IAM user because of the use of the wildcard there, the action of put item to a DynamoDB table, except for this Forbidden Forest DynamoDB table, this allow will not work on this Forbidden Forest table. Now, all the students at Hogwarts have access to put any. Okay, we already said that. Now, here is our question for the last task in this room. As headmaster, Dumbledore's IAM policy is affect, allow, action, wildcard, everything, resource, everything. Would he have access to the Forbidden Forest if the second policy were in place? So basically, the question is, would this policy override Dumbledore's IAM policy that he has like God mode in the AWS account? Okay, so first of all, let's see what we can figure out about this policy. So we see the principal here again, right? So this means this is a resource policy attached to the Dynamo table, probably. And another thing I noticed in this resource policy here is that there is not an explicit deny, right? There is an allow, and then there's a not resource, but there's not an explicit deny. And there is an explicit allow in Dumbledore's IAM policy for any action or any resource. So that makes me think the answer is yes. And let's see if I'm right about that. Okay, correct. So again, no explicit deny. That was a good question and a good example of no explicit deny and an explicit allow should equal to permission to do the action. So that is the IAM permissions room done. I really liked that room. I think it illustrated those concepts quite well. And now I'm going to go ahead and move on to the next room in the IAM module. So hopefully I will see you in the next video walkthrough, and thanks for watching.